Tell me the answer to the DOM. Whoa, 837? First thing you needed to do is put it over 999. Oh, excuse me. And then reduce it as much as you can. And was it 8 over 37? Easiest way to do this would have been on your calculator. So, first thing you want to put in is 216 over 999. Remember, that's the secret. You just put the amount that's rep-attended over that many nines. Then hit math, enter, enter, and it should put it into fraction notation for you in reduced form. Any repeated decimal? Technically, we did this with the use of any infinite geometric series, a1 over 1 minus r, but essentially the key was just take whichever portion the repeated part is, put it over that many nines, and reduce. That was it. Like, if it was 0.7 repeating, it'd be 7 over 9. If it was 0.727 repeating, it'd be 727 over 999. Reduce as much as you can. But if you hit math and enter, it reduces it for you. Other questions about the DOM? Alright, here we go. Number 1. Now this shouldn't take quite as long as normal because you have a test in front of you. You don't have to write down the questions. So, yes you may. I am going to put a question up here. I'm going to give you about 1 minute to look it over. See if you can figure out which formula we're going to use, and then we're going to solve it. Biggest thing, when I put it on the board, you can rush and try to solve it, but the biggest thing I want you to just look at is, do you know how to solve it? Do you know what formula you're going to use? That's the important part.
Will we be able to use this for
Yes. And you're not the only person to have asked again. Yes, we can use this on the test. Who can tell me what formula I need for this? Kim. That's correct. If r is greater than 1, then an infinite series won't exist. Well, what is our r? What is it? 1/4. Take any term divided by the previous term, and that will give you the r value for a geometric, which is 1/4. And being less than 1, what is our formula? You got it. A sub 1 divided by 1 minus r. So, what is our a sub 1? 96 divided by 1 minus r, and then you can just plug it in the calculator. That's 96 over 3/4, which is the same as 96 times 4/3. I'll slow down, let people write. What'd you say? The formula that we wanted to use for this one was this. Any infinite geometric series, excuse me. The key here is infinite. You only use this formula for infinite geometric series. A sub 1 divided by 1 minus r. Here's a sub 1. We found r by taking any single term and dividing it by the previous term, which we got 1/4. 96 divided by 1 minus 1/4, so it's 96 divided by 3/4, which is the same as times 4/3. Yes, thank you. That's the first term. Stakes off. The first term. A1 stakes off? No? Okay, thank you. What is wrong with you? Okay. Any questions about that slide? About that question? Alright, here we go. Number 2. Who can tell me what to do for this? Ben. There you go. What is that? 3 halves? So we can cross off A, because it's the only one that doesn't start with 3 halves. Then what do I do? Do it with a 2. That's right. You just keep plugging in the next number for n. So that's 9 over 6, which reduces to what? 3 over 2. We can cross off C, because it does not have 3 over 2 in the second part. 2 plus 1. Factorial, which is 3 times 2 times 1, which is 6. Then we plug in a 3. 3 to the third is 27. 3 plus 1 is 4. 4 factorial is 1 times 2 times 3 times 4, which is 24. What does 27 over 24 reduce to? 9 over 8. So our answer is B.
So anytime you see that exclamation point, it's just like doing that kind of thing.
Yes. What a factorial is? A factorial is just where you take a number and multiply it by every number under it. Yeah. Right here? Yeah, don't forget the factorial. The factorial, any number factorial is where you take that number and multiply it by every number below it. So 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. It's just a math thing. Exactly. That's where we got the 3 halves from. Any other questions? Yeah. Now, I'll tell you this. Tomorrow, when they ask you for the first 4 terms, if you're afraid you're going to make an algebra mistake, the easiest way to get those terms would be to just plug it into the graph and then trace those values. That way, you don't risk typing in something wrong. So, had we done it like that, we'd have just done 3 to the x, so we're just going to use x instead of n, divided by x plus 1 factorial. I believe it's math. Scroll all the way over, number 4. Graph. Okay, we can't see it. That's not a big deal. Trace. Let's see. 1, 3 halves. 2, 3 halves. 3, 9/8, etc. I don't know why it's not showing up though. No, it doesn't look too. Good idea. Nope. Must be something with my stat plot. Nope. Well, it doesn't matter. Doesn't matter. We can still trace the values we needed. Questions about that one? Same way you do anything else. Yeah, it's just a math term. It'd be the same thing if we actually wrote in the number 3 times 2 times 1, etc. Okay, here we go. Next question. You're warm. Long sleeve t-shirt. Oh, it doesn't help. It is cold outside. Pleasantly cold. It's 57 degrees in my house when I got this morning. That was amazing. Makes the covers even warmer. What's the only number this thing could possibly be discontinuous at? So we can immediately cross off A and C. The only possibility, there's no denominators here, so the only possibility is where it splits. So it's either 2 or none. What? Because the only chance that it's continuous is at 2, not at 3 or 0. Now, if one of these was over x minus 3, then 3 would be a possibility. If one of those was over x, then 0 would be a possibility. But with no denominators, the piecewise is the only possible chance for discontinuity that we've looked at. So, how do I find out if it's continuous at 2 or not? Plug it in. Yeah. Well, I get 6 for this one and 6 for this one. Yeah? Now, before we go any further, the fact that these two are 6, if this was a question asking about a limit, the limit would be 6 and the equals wouldn't matter. Because the left and right sides would be the same. But, for continuity, we need all 3 of them to match, and they don't. So the answer is, it is discontinuous at 2. This is what this would look like if you graphed it, ish. Line, a line that stops, but then the parabola picks up. Now they both go to 6, but unfortunately our actual value was here. So that's what that would look like if you graphed it. Had that middle one been 6, it would have filled that in nicely and would have been continuous, but not the case. Questions? What questions do we have about this one? Okay. Next, another one. Oh, it's the same directions. For what values is the function discontinuous? What are the only possibilities for discontinuity here? 3. It's the only possibility. So we can scratch. Oh, not that one. We can scratch off 9 and 3 and 9. 9 has no possible way to be an answer. It's not x minus 9, and it doesn't split at 9, so that's not possible. So plug 3 in, and what do you get? 0 over 0. What do I do when I get an impossible fraction? What? Right, plug it in and trace. Or you could factor, and this one does factor to x plus 3, but let's go ahead and put it like this. X squared minus 9 divided by x minus 3. Graph. Now standard window. Before we trace this, most common error I saw in your homeworks was that people would trace at x equals 6. That is the y value. You want to trace around the x value. So what am I going to plug in? Not everybody all at once now. There you go. And what are we hoping it equals? We're hoping it equals 6, the y value. Looks like it is going to that. Now let me try the other side. What do I plug in for the other side of 3? Excellent. Oh, yeah. And we're golden. So is it continuous at 6? Yes. Now please remember what the directions say. Is it C or D? C. The direction says for what values is it discontinuous? So the answer would be none. There are no values where it's discontinuous. Should you forget that and write D tomorrow thinking that you had shown that it was, please show your work on these and I can give you your credit back. Questions on this problem? Okay. Numeral 5, limits. The graph of the function is given. Use the graph to find the indicated limit and function value. Typo. Or state that the limit or function value does not exist. So we're finding the overall limit and what the function actually equals at that point. What's the limit going to be? 0. The graph approaches 0 from both sides. So it has to be, well, only one of these has a limit of 0. Which one is it? B is the only one that has a limit that equals 0. The other ones equal 1, -1, and does not exist. No, it didn't. We didn't even end up needing part B, but what is f of 0? Yeah, there's no dot anywhere. There's no dot. It just doesn't exist. Had it been like up here, just some random dot, then f of 0 would have equaled 4 in this case, but it didn't. So questions? Which part? Limit as x approaches 0. Now notice this has no minus or plus after it, so it means from both sides. So as x approaches 0 from both sides, is it approaching the same y value? Yes. And what y value is that? 0. And it was the only one that had a 0. And then we didn't even end up needing part B, but since there's no dot, you could say that f of 0 does not exist. Okay. Other questions on that one? Next one's very, very similar, except notice it's not an overall limit, it's only a right-sided limit. Who can raise your hand and tell me what the right-sided limit is? Kelsey. Very good. The right-sided limit as x approaches 1 from the right is 2. So it has to be A or B. What is f of 1? 2. The actual dot is at 2. So which one will that give us, A or B? Very good. A. Questions? Questions, comments, concerns, anything like that? Nope. Okay. Use the formula for the sum of the first n terms of a geometric sequence to solve. I'm going to give you seconds to look at that one and dig through your notes, and then I'll call for volunteers. Excuse me? Impressive. Well, I'm going to ask you for the answer, but I'm going to... What formula am I going to need for this? Well, what is that formula? I don't think that's. I think that's the arithmetic one. Does anybody have geometric sum formula? That's arithmetic. Natalie. Very good. That's the formula you're going to need for a geometric sum. What is a sub 1? What is r? -3. Take any term, divide by the one previous. If there's a 1 anywhere in your sequence, hey, use that because that's easy. 3 divided by -1 is -3. So that's my r. And what's my n? 11 over 1 minus r, which we've already said is -3. And we're ready. So that's going to be 1/3. I don't know. Actually, let's just punch this in the calculator. That's kind of gross looking. Calculator. On. Clear. Parentheses. 1/3. 1 minus -3 to the 11th. Divided by 4, basically. Yikes! So which one is that? Well, let's see, math, enter. Give it to me as a fraction calculator. Aww. I'll just multiply it by 3, I guess. Times 3. So that's the same as 44,287 over 3. And the answer would be D. I'm sorry? They probably wanted you to do it algebraically, which you can. You could have done this one piece at a time and done it algebraically. You didn't. To find your R, you take any term and divide it by the previous term. So you could have taken any one of these terms and divided it by the one previous and got -3. If I ever see a 1, I like to divide by 1 because that's easy. So I did 3 divided by -1, -3. Other questions? All right, moving on. We're already 35% done. A twofer. I'll just give you a chance to look at these and answer them in your head. Good thing we're talking about it. Very good.
So has that sign actually those people from
I don't know, but every teacher or administrator that walks in here notices it. I did have one question for you though. Why is the blood on that sign? People watching the video are gonna be really disturbed if they don't know what we're talking about. But why is the blood on that sign kind of like globulating before it falls? You know what I'm saying? It looks like it's like glucose based.
It could be. Like you could use some like plant
Just because it's red. If you were to make that a different color, it would look more like honey or something. Anyway, who can answer number 8 for me? That's right. Before we go any further, is there a denominator or piecewise in number 8? And we never looked at radicals, so there's no chance it would be discontinuous anywhere. So it doesn't even matter what value it gave us. Okay. It's like all these that we graphed on the board. The only one of these that was discontinuous, you know what, forget this.
What's the thing that was on the right?
Continuity. Continuity means are there any breaks, holes, or anything funky happening on your graph? And the only things that give us that are zeros in the denominator, piecewise functions, or negatives under a radical. Now, does that have a piecewise? Does it have a denominator? Does it have a radical? Then it's continuous everywhere, regardless of what point we're plugging in. Like one of the ones we just did where it has multiple functions.
So number 9
Of course,
would be
if that fails you tomorrow, if you forget that, then when all else fails, just plug in the value it gives you. If you get something impossible, it's discontinuous. If you don't, it's continuous. Yep.
So number 9 would be non-continuous.
That's correct. Because if you plug in -9, you get -3 over 0, and you can't get anything over 0. So that's why 9 is not continuous. Questions? No questions on that one? Adam, no questions? Oh yeah, I guess you would. But even if you got 0, that's still fine. You just can't get a 0 in the denominator. Okay. Use the formula to find the general term of a geometric sequence. All right. So I'll give you a second to filter through your notes. General term of a geometric. No, that was a sum. This is a general term. Like, what's the 15th term? That's the general term. Whereas the sum would be, what's the sum of the first 15 terms? I do. Thank you. Very good. What's my a sub 1? So we're looking for a sub 11. So that's -5. What's my r? And what's my n minus 1? Very good. It's just n minus 1. So you can punch that into the calculator. I'll give you a chance to do that, and somebody can blurt out what the answer is. I'm betting it's not D. Where? Right here? That's r to the n minus 1. That's a exponent. You a sub 1 times r to the n minus 1. Bravo. I reckon that's correct. Questions? Click. Use the formula for the general term of an arithmetic sequence. Find the indicator term of the sequence. So, I'll be needing that formula. Awesome. So we're ready to plug in. We're looking for A sub 31. What's A sub 1? Next. 31 minus 1, which is 30. Almost negative 2/5. Bunch in the calculator. Is it? You got B? That's what I got 2. One was arithmetic, the other was geometric. Geometric is you're multiplying by a number every time. Arithmetic is you're adding by something every time. Yeah, this one you're finding the 31st term. That one you're finding was the 11th term. Well, it all depends on your pattern. Like if you have a pattern that's adding something every time. Okay, all right. Yeah, yeah. They're definitely two specific times when you use each one. Question. We are rocking and a rolling, moving and a grooving. 55% done. Click. Nope. Go back. Click. By the way, before we go to the next slide, one thing which I don't think we really talked about very much, that last section we did, where it said, here's a function, and it said, find the equation for the slope of the tangent line. Remember all that? Another way that they'll word that is find the derivative of that function. Finding the derivative is the exact same thing you were doing. You're doing the f of a plus h minus f of a all over h thing. But that's why in the next function, when it says find the derivative, and then once you find the derivative, plug in this value for that, that's all it is. F prime of x is the derivative of f of x. That's just a vocab word. So, we need, since that's the first time we've used this word, I'll just jump straight into what we're supposed to be doing. This is where you find the derivative f prime of x by doing the limit as h approaches 0 of f of a plus h minus f of a all over h. Limit as h approaches 0. That formula is never changing. Easiest way to do this is to find out what f of a plus h and f of a are first, and then just plug them in. F of a is easy. You just basically take out the x's, plug in a's. So let's go ahead and throw that in there. Caleb, what's my f of a plus h going to be? Yep. Very good. Very good. Now we just have to filter all that down. So, FOIL a plus h, and it's going to be the same thing every time. Minus 8a minus 8h minus 11. And there's nothing else we can do with that except for drop the parentheses. So it's ready to go into the formula, which I will switch colors to indicate we are switching gears. We're going to come back and look at the limit here in a second. So first thing we're going to do, we're just going to plug in f of a plus h and plug in f of a. Minus. If you do it right, what should cancel every time? Everything on the right-hand side. Muchos goodos. So, does it? A squared, 8a. I should change colors for this. 8a, 11, 11. And what are you left with? What factors out of the top? It should be the same thing if you do it right. and h factors out of the top. I beg your pardon? What cancels? H. I should have switched to red again. So that brings us down to over here. Now you need to bring the limit down. So it's the limit as h approaches 0 of 2a plus h minus 8. So when you take that limit, what's it going to equal? I'm sorry? 2a minus h. Which means, oh, it's 2a minus 8, right? Yeah. Which gives you f prime of x equals 2x minus 8. What? I'll backtrack here in just a second. In fact, I'll just do it now. We'll stop there for a second before we plug in our value. What questions are there? From which step are those questions? Nobody has a question? Everybody's head's hurt, but nobody has a question? Okay. Then it says plug in 6 for our equation. So, f prime of 6 equals 12 minus 8 equals 4. So the answer is bravo.
Yeah, how did you do?
Which one? Here? Then you just plug in 0 for h by the limit. So that's why it went away and gave you 2a minus 8. But once you've done all that, it basically just turns into an x and gives you your derivative equation. I didn't. I took it out an h here, an h here, and an h here. Took just one out of everything. You have to. Because if we factored it, you can't factor something unless it exists in every element. Other questions from this problem? Yep. Once you get to your f prime of x, you're ready to just plug it in. Question? Okay. Anybody need me to leave this up there for a moment? Adam, you need me to leave this up there for a moment? All right. Here we go. Indicated sum. You could either write this out or plug it into your calculator. I don't care which. We'll write it out, then plug it into our calculator, because we just have all kinds of time. Who can tell me how to write this out? Braden, come on. You know you want to tell me. Yes, you do. It's sweltering hot. No, I mean, like, if you weren't to plug it in the calculator, because most likely we could very well mess up on a comma or something tomorrow. Although I can help you. If you have everything put in there right and you're just having a problem with a comma or parentheses, I can probably help you with that tomorrow. But if you just hand it to me and be like, I don't remember how to put the calculator, I'm like, tough nugget. If you already have the functions in there, I can help you with commas and parentheses. But I'm not going to help you know what buttons to hit. Yeah. Yes. Alright, so that would be 4 factorial over 4 minus 1 factorial plus 5 factorial over 5 minus 1 factorial plus 6 factorial over 6 minus 1 factorial plus 7 factorial over 7 minus 1 factorial. You start here, stop here. That's right. Now, trick to these, how do these reduce? Rather than plug all this in the calculator, yeah, because remember, if you have any value, I don't know if you remember this when we did this in the homework, but this reduces to n plus 1 because this is just n plus 1 times n times blah, 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 blah. Essentially, here's what we're talking about. For every one of these terms, this is going to happen. This is just the first term I'm doing right now. What all cancels? And you're just left with the 4. This one's going to be 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. So the only thing that's going to be left in all of these is just that highest one, as this one turns out. So what's 4 plus 5 plus 6 plus 7? 22. Now, to punch it into your calculator, because there's a good chance that tomorrow's won't be quite this easy to reduce. I mean, you could just punch all those in individually in your calculator and add them up, but that would take a little bit more button pushing. If you wish to do it on your calculator, here's what you do. Who can tell me what to do? How do I get the sum? Second stat. Very good. Go all the way to math, sum, second stat again, go to the middle one for sequence. Now, what do I push in? That's right. We're going to talk about that in just a second. Now, do I have to put my denominator in parentheses? Then it's probably, well, I don't guess you have to. Yeah, then it's probably important that you just put your whole fraction in parentheses too. I don't guess you would have to, but why what? I guess we can. I'm just a, okay. So what is it, x minus 1 factorial? Touche. Oh, dang. We would. Okay. Now, once you've got the equation in there, it goes comma, your variable, comma, your starting point, comma, your ending point, and then you'll always tell it to go by a step of 1, 22. If you choose to go the calculator route, that's how you do it. Again, if you're having error tomorrow, before I will help you with the calculator, I need to see the sum sequence part in there. That shows me you know how to do it. If you've got some sequence, I can help you figure out the little bitty things that's going wrong, commas and parentheses, all that stuff. Question? Okay. Click. Find the sum of the first 30 terms of an arithmetic sequence. I'm going to need a formula. I don't know why, but I decided to go really big font. What is n? 30. What's a sub 1? What's a sub 30? I don't know yet. That's right. You got to do general term first. And what was that formula? Yes. Excellent. So that's 10 plus 30 minus 1 times d. Huh? So that's negative 145 plus 10, negative 135. So 15 times negative 125. Yes. Wait. This? No. D is your common difference. It's what you're adding or subtracting by every time. So remember, in an arithmetic, to find D, you take any term and subtract the previous term. So I'm thinking negative 5 minus 0 might be the easiest combo to do there. And you would get negative 5. For geometric, you take a term and divide by the previous. Arithmetic, you take a term and subtract by the previous. So the answer is A when you plug all that mumbo jumbo into the calculator. Oh, excellent. Just a moment. Questions? We are 70% through. Come in. Yes, please. Lays, if you could just get up for 1 second, let him get to that air conditioner. Take a quick break while that's happening. Who did something exciting this weekend? That's not exciting, but yes. What? Oh yeah, what are you taking? Algebra? What is that? You should have no problem with that. General psychology. With Ritter. It would make me feel younger if it was the same professor. What did you do this weekend, Cody? What? How'd y'all do? You can't just say you lost. It's not like Fast Five where either first or last. So you got second place? Out of how many? Wait, what? Well, that's good. You beat 12, 13 schools. You lost.
Well, Nathan Fox and Clay Conger got second place.
Oh, I was thinking it was a band. Okay. We wouldn't get in the top 35%. Thank you. We're going to keep going. You know what? This was meant to be a pleasant conversation. We're just going to keep going. Okay, I don't care. I opened up a can of worms there. Who can tell me this one? The question was who can tell me? And Chris is the only person who got that question right. Can you tell me?
Yes.
And what is it?
The answer is B.
Aw, you're right. Any questions about this one? It's the exact same thing as the DOM, just 1 9 for every digit under the repetend. Repetend. That's a funny word. You know, if you take repetend and mix up the letters, it's I pretend. But we're not pretending. That's really how you do it. I don't know. I'm going to hope so. Okay. This one, you have to tell me which summation is the correct one for that sequence. Easiest way to do it is just go through each and every one of them and plug in the numbers and see which one gives you those fractions. No, you would, well, like, let's say you start with A. You plug in 0. So it'd be 0 over 0 plus 2 is what? What's 0 over 0 plus 2? Is 0 the first term? So this one's out. So you go to part B. You plug in 1. 1 over 1 plus 2 is 1/3. That's correct. So we go on. Don't just stop after 1. So you go on to the next one. Let's try a 2. 2 over 2 plus 4 is 1/2. Is that the second term? Yes. So far, so good. Let's try 3. 3 over 3 plus 2 is 5. That works too. Let's try the last term. 10 over 10 plus 2 is 10 over 12, which reduces to what? So we're thinking it's B. You can go ahead and try C and D as well, but I think you'll find that they don't work. It is B. And that's how you find it. Just making sure you know how to deal with a summation. 80% done. Number 17. Finding the limit. Use the properties to find the given limits. That's right. On A, you would use the top one. So if you plug the top one in, what is it? Okay. So we can cross off D because A is not 5. How do you find part B? Look at the bottom one because it's greater than. What is it? 5. So we can cross off C. So what is the overall limit? This is the moment of truth. Because it said that B was 4, but B, the limit from one from the right, if you plug 1 in here, is 5. So it's not 4. Because the second term tells us what it equals. It doesn't tell us the limit. We crossed off B. That's right. The answer is A. Because it's asking us for the limit. Remember, for a limit, the only thing we care about is do the two sides of a limit agree with one another, and they do. Remember, this is one of those problems in our when we did it that I said you can completely mark through the equals part. When it comes to a limit, we don't care what the point equals. We only care about what it's going to. So the answer would be A. Probably one of the trickier ones, just because they put that in there. Oh crap! What? Oh, well, let me. Well, anyway, the answer's
You
A.
know you gotta go by the big A, not the little A.
Oh, touche. There we go. So the answer is A. Questions about why it's A and why not something else? Sure. This is what this implies, okay? And then I'll explain it a little more even further. A piecewise is multiple functions, right? So they're saying up until 1, so here's a coordinate plane, we'll call this 1. Up until 1, we're using this function. 6 minus x, it's this right here. And then it stops. Then they're saying at 1, y equals 4, which is here. And then starting at 1 again, it's this function, which is a parabola looking like that. Now, if I just gave you the picture, and I said, what's the left-hand limit? You'd say 5. Well, assuming you could read this. 5. And I'd say, what's the right-hand limit? 5. What is the overall limit? Remember, the only thing that matters there is, do they agree? And yes, they do. They're both going to 5. We don't care one little bitty bit about what the point is unless it asks for it, but it didn't. It just asked for a limit. And limits don't use the point. They just use what the point looks like it should be. Biggest, most confusing thing about this one is because it looks so similar to those continuity problems. Now, if this question had said, is it continuous, then we need that point. And the answer would be, no, it's not continuous because this, it breaks right there. Whereas if this had been here, it would have helped us because then it would have been continuous. But it didn't ask us that. It was a limit problem. Well, the three limits are already the same. For it to be continuous, yes, even the point would have to be the same. Yeah. Oh, you meant on the piecewise. Yeah. Other questions? No? All right. Find the slope of the tangent line. That's just another one of those take the derivative, plug in the value kind of things. What number here do we not need whatsoever? No, that's the one number we do need. You don't need the 33 at all. So here we go. Just like before. Who can tell me the formula this time? Can you tell me what the formula is? That's right. Muchos cuidados. So we need f of a and f of a plus h. You don't like these problems? Well, there's only two of them on there. That's good. So it's 2a squared plus a minus 3 for f of a. F of a plus h, a tad more time consuming. So that's going to be 2 times squared minus 3. Yep. Yep. Then you have to expand it. What does this? Plus h squared. Yeah. 2 times a squared plus 2ah plus h squared plus a plus h minus 3. Only thing we have to do now is distribute this pesky 2. There we go. And we're ready to plug it into our formula. Woohoo! Another one excited by this? Okay. Chris, what do I do now?
If you want
Well, you're 2 steps ahead of me. Yeah, what do I do, Braden? That's right. Oop. Darn it, let me just erase that. Dadgummit. Hey, I'm not slacking, I just have bad handwriting all the time. I take offense to the fact that I'm slacking. How do you say slacking in Spanish? Spanish people don't slack, so why would we need that word? Okay. How does that mean? That was a compliment. That was a compliment. 2a squared. I think British people had it first, and they do slack a lot. Okay. 4ah. If there's any British people in here and I've offended you, I don't care. 2h squared plus h.
What if there's somebody in Great Britain watching this on YouTube?
Like that bloody wanker? Okay. So, factor out an h. That would be hilarious. You know what? If I'm getting British people watching this, then I'm a success at life anyway. So, cancel. I'm going to get a call from like the royal family. What did you say? Alright, so what do I do once I've reduced everything? That's right. What's that going to happen? What's that going to happen? What's that going to do? What? Very good. What does this turn my equation into? Context clues of the finger point, Hannah. What do I plug into my derivative function?
4.
That's right. And when I plug in 4, what's it equal?
17.
That's correct.
Oh,
That would give us C. Oh, yeah. Would that be what like a confused ostrich would do? I can't find any sand. Devin, I bet you yell at Matt all the time, don't you? Yes, you do. Do you cough and say idiot under your breath ever? Like, go, it's green, idiot. Why be subtle? Okay. Questions about this one? Everybody got this written down? Yeah. What do I do? Plug it in. What do I? Yes, ma'am. You know, that's a good question. I believe there's some formula where it's like x minus 2. Oh, that should be a minus. And then it's like x squared plus 2xy minus y squared. You'd have to ask an Algebra 2 teacher. I'm pretty sure that's how it factors, though. Actually, ooh. A good way to know that we learned earlier this year. How can I find out if x minus 2 is a factor of x cubed minus 8? Synthetic division, that's right. And I can find out if x minus 2 is a factor. No, you remember you always plug in the opposite. So you drop the 1, multiply. Drop the 2, multiply. And it's not. So it must have been plus 2, which would give me negative 2. Would make that negative 2, negative 2, positive 4, negative 8. Yeah, which means you factor the bottom like this. X plus 2, and then what's my depressed? X squared minus 2x plus 4? Go figure. That's how it factors. Depends on what the math is. But yes. In general, yes. Yes. Easiest way to do this is just to plug it in. But now I'm like really excited about this So if you plug 2 into that, you don't get 0 anymore. You get 0 over, that's not right.
You broke it. You broke that.
No, you don't. You get 4 minus 4 plus 0. Negative 2. Add. Negative 2, positive 4. Dang it.
Don't hurt yourself, Ted.
I'm at negative 8. It's a minus 8. Which means my original was fine.
Cry about it.
Okay, now we're good. Which I was right the first time. X minus 2. Okay, so this part cancels. Okay, so then you plug in 2 and you get 4 over 4 plus 4 plus 4 is 12, which reduces to 1/3. Of course, if you don't like doing synthetic division, should you fall short in your factoring prowess, you can always just plug it into the stinky calculator. I can't believe I made that boneheaded mistake.
It's alright.
Really ticked off.
We expected that.
To have found the... When you get that excited about something, you just need to get it right on the first try. Because it's like the boy who cried wolf. They're not going to believe you the second time you get excited. Graph. Okay, so what am I graphing? Near 2? What do I punch in for values near 2? Please be close to 1/3. Please be close to 1/3. Yes! Whoa. Why did you give me scientific notation? Oh, I forgot to put my original in there. Oops. My bad. Cubed minus 8. Delete, delete. Try graphing that. That's going to be much better. 1.9999999. Please be 0. I mean 1/3. Yes, it's 1/3. Of course, then you could punch in 2.00001, and it is also 1/3. We did it, everybody. We did it. So, yes, you can factor if factoring what you want to do, or you can punch it in your calculator, trace values near your limit value. Some people, I know the majority of the limits we did in here were as x approaches 0, so people just kind of got into a rhythm of 0.0001 and negative 0.001. But remember, you trace values close to your limit value. That's what determines where you trace on your calculator. Other questions? See, British people would have given up on that problem because they're slackers. Okay. Now if I plug in a 1, what do I get? You're totally just guessing. Is it 8 over 1? Which is 8? You're right. Don't just start tracing until you've plugged it in. Maybe it has a nice, easy little answer. And we are 100% done if there's no questions.
See, now, did all that